also a little complication is that somehow the cloud has a memory limitation that we were not able to use the initial. This program basically does the kind of partitioning and combination tool. We were not able to use it. We have to change somehow, adopted to the cloud cluster. But if you do on your own, and you have a better computer, you just use this one, is fine. That's when I used in the the North Carolina Research Triangle computer. It just worked fine. But it moved on the cluster, we had to modify a lot this program. But just tell you that. So now I think we are all set. You can go to work and make this the PP I think preparation and post-processing post-log. Let's see. It works. So now I think we have everything we want. We want to use this one, we want to use this one, and we want to use this one. That's it. This is the first step that we did. Now, let's see to run it. Run it first, we will try this one. Try this one. When using one single CPU, we can test, we can submit the job. So here I see, and what we do here is that this message, I think the 30 box is much better because all the forcing files are here. The control file, let's see which one is this one, right? Is this one. This is a control file that Carl talked about this morning. But this morning there are a lot of files located in the input folder. Now they are all messed up here. They are located here. This we just used to do this. And he asked a lot of, the loading files. We can talk, this is the point source loading files. And this no point source loading files. They are all here, the map files. I think, and Carl talked about, meteorological forcing files. They are here. Anyway, so now everything is here. And we can run directly the model. And this here, I just put the result that I got it earlier. We will work on this result, this output of the simulation. So, but this generated earlier, we can see that. Okay, let's see. I'll see which one. Sorry. So, it's in March 5th. This is all result. Whatever, So now I'm thinking how we do it. Let's see, the code is located in, I think here, in this one. This one, we want to run this one. Right? So, what we should do? We should have S1, right? And 1, or together with the fun too. So let's see. Okay, let's see the button. Submit it. You don't know that, submit it. That's fine, I just because it's submitted. Look here, this is the one we submitted with one single CPU. And waiting for results. So most likely we would need more than 9 hours to get the result. We will come back to check. Now the job is submitted.
So one CPU, how long would it take for run a year?
For 1 year is about 9 hours.
So
Yeah,
that's pretty
9 hours.
And that's, how can one CPU be that fast?
Oh, it's pretty fast, yeah.
That must be one heck of a fast CPU.
Well, it's one node, right? But it's 36 cores.
No, it's only one.
Just
core.
one
Oh, it's only one core.
On
one
one
core.
core.
So that's like a,
Wow.
But only 1 year. Only 1 year.
Yeah, still, but I
but
mean,
still
yeah.
fast.
Yeah.
it's still,
Yeah.
that must be a blazing fast processor.
Yeah, it's pretty fast.
Huh.
Still waiting, that's fine. Okay, now with the furnace things is run in parallel. Let's see, we do here. Again, it's everything are here, you know, not well organized. But to run this, you have to do 3 things. First, decompose the things. Okay. Second, run the model. And the third, combine the result. Right. This result is post-processing. So first we have to decompose the things in this one. So you can look at what it does. Basically, this we call it slum scheduler. You just tell the computer, I want 1 CPU node, whatever, and here I just want 1 node, 1 task. Is basically is one CPU because you decompose. You're not doing the parallel computation yet. Now here is the key thing. This is executable. You must type prep. Prep means prepare. Prepare means decompose. You must specify this number. I mean that I want to partition into 32 domains. So this is what it does. But today it's kind of, you know, if we submit this, we wouldn't need to wait for resources again. So we can do it, you know, but this is not allowed doing this. But we can run it on the must node. It's available immediately. And John does not like us to do this because at this moment that if everyone does this, it risks to crash the must node. So that's a risk. But today only one, I would think so. That's not good. So now we just do this one. And yeah, it started to decompose everything. And this is the initial condition, decompose. A lot of extension, yeah, just go on. But sometimes it's slower because it's the hydrodynamic forcing files. It's huge. So you take a little bit of time. But I think in total it's 8 or 9 minutes that will go over. Even shorter than that. So we can just wait a little bit, you know. Instead, if we submit it to the computation node, we would need a first resource then, you know, do the things. But now we can check our job. Why do this? So this command is just to check how your model are running. Something wrong. Look at this. We submitted probably 10 minutes ago, still waiting for resource. It just, I noticed that when since a while you did not run anything, when you restart, wait a long period of time to get the resource. When you continue doing that, you know, it's much faster. I don't know, this is something that, anyway, this means that a single CPU job we submitted did not start yet. Just tell them. Yeah. And we have to, yeah, this is the vision. So we can go there to, okay. Look at this. Look, before this pollutants did not exist. It's just when we do the decomposition, it creates a folder for each CPU. Yeah, this is the totally 31, but from 0, this is 32. So we can load things inside. Look. If you all of these files, for example, the control files, you just made assembly 32 copies, and each CPU must have these files. We have also, I think the initial condition is much smaller than the using a single CPU because it's just a decomposer. Let's see, let's check. But they must bear the same name because it's the name in the control file. So let's see, this is how much? K M, right? Non-M, right? K M, non-M. What I did? Oh. See. This is how much? It's just 400K, right? Basically, your initial condition divided by 32. Right? Not exactly, but much smaller. That's what it is. Otherwise, we can check a couple of them. And we are waiting. And identical, the same. This must be the same. Let's see. And let's see. This is, I just saw this one, so we just do this one. Or this one. Ah, you would be. This one is the phytoplankton growth that we talk, really, is defined here. And this is the same because just make a copy. We can do a comparison. No, sorry. This one with this one. Oh, wow, what the heck? So that's something I didn't understand. But you can see that the number are the same, right? The number is the same. I think the number of line are the same. Yeah, all the same, all the same. Yeah. Anyway, I just want to show you that this identical. They are identical. We just did a copy of it. So and we are let's see if it's or not. Yeah, almost done. And we are waiting.